I'd like to welcome you out to our live stream tonight. There's a few people joining, and we're going to kind of just wait for people to trickle on in. And there we go. Hi, Chase. Good to see you. Um, we're going to be talking quite a bit about what blockchain is. This is kind of the introductory the introductory week. So I want to get you off to a good start as to what blockchain is and what we're going to talk about in relation to in relation to blockchain. So give it a couple minutes. Right now we have I have my assistant online as well as three other people. Hi, Chris. Good to see you. And Jacob. Very good. Very good. All right, so that's our three people that are with us right now. That's good. So what we're going to do with this is I have the chat window just a little bit to my left over here. So when I look over that direction, I'm just looking at the chat window. I also got a couple canned articles to put up, and those canned articles will be things that will start introducing the topics. And we have Chelsea that just joined us. And good. My assistant said the sound is doing good, so that's good. That's good. So, and Lance joined us, and Nicholas. Hey, very good. Very good. And thank you for letting me know your name. My assistant is going to take and scribe the names down so that I make sure I give everybody credit that's been here. The whole idea of the weekly get-togethers is so that you can have access to me. I've tried a variety of things. I've tried using the canned audio and video in Canvas, and it just was pitifully inadequate. Especially if you have me not on the Lindenwood site and using their stronger servers and such. Me going virtual, and then you guys joining virtual. It just didn't work very well. We tried a variety of other technologies. So now this is kind of another evolution. We're going to go with YouTube, and hopefully everybody will get a good clear picture. I was able to get a good stream going, and it says the stream health is excellent. So we should have a good time. So post your questions that come up in the chat room. I will tell everybody what the question is, and then I will proceed to give an answer to the question. Okay. So if nobody has a question to start us off, I'm going to go ahead and start us off then. And I'm going to start with kind of what a blockchain is and give an overview a little bit of what we're focused on. So blockchain is a technology. It is a technology that many have likened to a database. True, it is a repository for data, but there's some very special things about the data in that when you put the data in, it gets recorded, and then more blocks keep getting written afterwards. And because of the encryption that is done between the blocks and in the blocks, in order to change any data within a previous block or any data at all that happened prior to today or now, you have to unravel all of that encryption, change the data, and then redo everything after that, which today's computers can't do that. And they're working on encryption schemes that will handle quantum computing as it starts coming up, and we'll talk about that in a future week as well. So when we go to IBM, I like to go to IBM because IBM is one of the leaders in implementing blockchains around the world. They have several blockchain projects, and you'll hear about me talking about TradeLens, which is an IBM project with Maersk Shipping. And so in the weekly lecture videos, I'll use the Maersk example there to share what the blockchain is and what the blockchain does. So the biggest thing is it is a shared immutable ledger of data. Okay. Now, what that means is that blockchain, and I can liken it to Bitcoin the best. You've heard about Bitcoin miners. Bitcoin miners all process the transactions of Bitcoin on the Bitcoin network. So I can set up a miner in my house, and I can set it up to start doing mining. And even though they call it mining, they kind of liken it to digging for gold, because Bitcoin initially pays out a number of Bitcoin for each person processing a block. Okay. Now, the details are, much more broad than that. But in essence, those miners are the people that do the transactions. Every single miner has a copy of the ledger. And that's what it means by shared. And immutability is determined or is achieved by the fact that if somebody wanted to change the data, they've got to change the data on all the miners' machines. So they've got to change every person's copy and effectively take over the whole network. And theoretically, that can happen if the network were taken over by bad actors that were able to capture at least 50% or 51% of the mining capability on the network. And see, the same would be true here. Although in business, what we're doing is most of them are permissioned, and because they are permissioned, they are able then to bring in actors that they trust. So let's say Maersk gives access to a shipping receiver, let's say the port of Los Angeles, for example. So they give them an account so that when Maersk comes and docks and takes their shipping containers off their ships and unloads in Los Angeles, the people in Los Angeles, the receiving people, have access to the Maersk blockchain network. And in that way, they are able to process the bills of lading and process all the paperwork, the customs, and all of the information and data that had to be done manually and on paper. So this is how blockchain is so effective. Okay. Hi, Danielle. Good to see you came. So what it does is it talks about it processes and records transactions, and basically it tracks assets, and assets can be a lot of different things. On a Bitcoin network, of course, the asset is this digital coin called a Bitcoin. If it's in the real estate market, if you've ever bought or sold a house or you're acquainted with that process, you go to a title company, and the title company has you sign all the paperwork, and they make up all the paperwork and get all that done. That information is an asset that's tangible. The transfer of the money, for example, in escrow, the processing of the paper, the communication with everyone that needs information concerning that real estate transaction. And then it actually can help change the ownership or track the ownership of a real estate transaction or pieces of art, or if you're in a supply chain, the raw goods from the company that digs it out of the ground and manufactures the raw metals all the way to the processing that is done through suppliers and eventually to their final product and gets to fly out or gets sent out to a customer. So it tracks assets. So it talks about the fact that it can be, a house, car, cash, land, or it could be intangible like intellectual property. It could be contracts, like they say, patents, copyrights, and branding. So realistically, a blockchain is very, very flexible to track and keep a lot of data. Now, the next paragraph, I really like the next paragraph because, why it's important is that business runs on information, literally. I can't put it any better than the way they wrote it there. And because it runs on information, it needs to process that information, it needs to analyze that information, and it needs to take action on what the information is telling them. I've worked at Boeing now for 25 years. And at Boeing, I process financial data. I write financial data systems that process this data. And it's amazing to me that we get so bogged down in the systems that we don't get the efficiencies out of the data that we really want. And so the blockchain networks can really help in that regard. So a lot of times a blockchain can track all of these items: orders, payments, accounts, production, and a lot more. As an accounting system, a blockchain is excellent. For example, if you're a large company, you get audited by auditors to prove that your 10K or your filings with the SEC are accurate. Well, how do you prove that they're accurate? The way you prove that they're accurate is you show them your accounting systems, and you show them proof that your accounting systems operate effectively and accurately. Well, it's a whole lot easier with a blockchain to prove that it's both effective and accurate, because the blockchain creates an immutable record of all those transactions that happen. Current accounting systems that are based on relational databases, for example, those relational databases, you can go in and change any data point you want. And in doing so, you then create a risk for the corporation, because you have to prove why all those transactions were changed. Now, in a blockchain, the transaction doesn't get changed. You'd put in another transaction that is a delta or an adjustment to that previous transaction. Then, so what happens is you can see both the original transaction and you see the new transaction adjusting it, and then you can have the justification for why that transaction had to have an adjustment right there in the blockchain. And all you have to do is make it available to the auditors, and it's very easy to go. So the efficiencies that are gained just in an accounting ledger are astronomical. They really create a lot of efficiencies there. So the key things that we'll talk about are these three all the time. We'll talk about the distributed ledger. And a distributed ledger is that ledger that gets shared among all the participants in the blockchain. We'll talk about immutability, the fact that it's hard to go backwards to change data, and because it's hard, it isn't done. They'll say that it's impossible. I won't say impossible, but it is very, very unlikely that any bad actor could go back and change records in the past. They say no participant can change or tamper with a transaction. Of course, we're talking to IBM here. They're going to say it's perfect. I hesitate to use the word perfect, because it seems like hackers always seem to find a way to find where they're actually imperfect. So then we're going to talk a lot about smart contracts. Now, smart contracts are rules that exist in the blockchain that automate certain processes. For example, let's go back to that title company. If you're the title company, you can go back and put these contracts that you have your people sign all in the computer. And you then are able to have a digital signature. But what happens is all the information gets automated. So it's a lot like putting data in a database. You put in the name of the person, the sale price, and all of the extra little charges that add up on a title document, and the computer then is able, through the blockchain, to spit out the full contract. So smart contracts are what can automate that. It can automate, for example, a transaction from a user interacting with the organization that has a blockchain front end. They actually have digital autonomous organizations, or DAOs, that function totally on their own, and all you're doing when you go to a site that has one of those or that works one of those is you're interacting with the blockchain, and the blockchain has the smart contracts to take your input and perform actions based on your input. So how does a blockchain work? So as you go down here, and by the way, if anybody has joined after Danielle told me that she was here, please make sure you tell me that you're there in the chat. Remember, the chat window is specifically so you can ask questions, so that you don't have to listen to just what I want to say the whole time. It would be nice if I didn't have to just come up with the whole lecture, but if I have to, we can do that. Okay. So the way it works is that a transaction occurs and it's recorded in what they call a block of data. In Bitcoin, for example, a block is generated every 10 minutes, and however many transactions happen on the network get put in that block every 10 minutes. So every 10 minutes, a block is closed. And they regulate that because they've got computers and they're doing computations, and they regulate that by making the computations a little less difficult or a little more difficult based on the number of computing devices that are out there and the amount of power, computing power, that they are contributing to the network. So blocks are predetermined sizes or predetermined time. And depending on the kind of blockchain that you're implementing within your company, you will get. Well, thank you, Danielle. I appreciate that. She made the comment, "I'm enjoying this," so that's good. Hopefully I'll make it valuable for you. Okay, so the block is put together. Once the block is done, and we're going to talk in detail how a block is assembled later on in the course. But when a block is done, it's closed, and then it gets a digital signature, and that digital signature is then recorded as in the header of the next block, and then the next block is compiled. And then when it closes, it knows the previous block address, or the encrypted value of the previous block, and the encrypted value of the next block, and then it hands the encrypted value to the next block, and it goes on and on. So every single block knows the previous block and the next block's encrypted values, okay, or signatures, they call them. Now, the only block that doesn't have that is the very first block, because the first block doesn't have anything prior to it, so it doesn't have, it's called the Genesis block, and you'll get to play with the Genesis block in the exercise that you do this first week, because you'll actually get to touch and see how a blockchain works and assemble some blocks of data, and that'll be fun. It kind of gives you an idea for the look and feel of how it works. Okay, so I already said that every block is connected to the one before and the one after it. That's with the digital signature for each block, and then after several are put together, it basically says they're locked together in an irreversible chain, or a blockchain, a chain of blocks. So as each new block gets put onto the ledger, remember the ledger is keeping track of all the transactions that are in the blocks, and it identifies the information there, and you can go search for it and you can find your transactions. In fact, on a Bitcoin network, if you know the transaction ID, you can find your transactions. If you know your wallet ID, your public ID, you can go look and see all the transactions on the ledger at bitcoin.org. So if you transact in Bitcoin and you know your wallet address, you can go search and see all your transactions and how they've been laid out, which block they appeared in, and so forth. It's really quite interesting if you want to just go play around a little bit. Okay, so what we're going to talk a lot about then also is the benefits of blockchain. And really, if you get involved in business a lot, you'll see that there's just a lot of waste. And maybe you've even worked at places where you can see a lot of waste, just in the motions and actions of what they do. A fast food place, the amount of food that they throw away, the amount of food that they cook and and don't actually deliver to a customer, that gets wasted out in the bin outside in the back. Um, there's also a lot of waste in just the time that's paid to employees. And frankly, a lot of that time is just because they want data, and the only way to get data a lot of times and turn that data into information is to have a person do this heavy amount of research and then understand it themselves so that they can tell a manager what is going on in a particular set of transactions or a particular program or various different functions within a business. So part of what is attempted then through like ERP systems, enterprise resource planning systems like SAP or other big ERP systems, is to try to collate all that data and make sense of the data for the people that have to make decisions. Well, part of what can happen with a blockchain is that it seriously speeds up the ability to get the information. And here's one example. Walmart uses a blockchain to manage their food produce that comes from the farms all the way into their stores. Now, the challenge with food is the problem with foodborne illnesses, like E. coli or other bacterias that can exist on the farm and not get properly washed or whatever as they come from the farm all the way from the food producer to the distributor to Walmart and on the shelves. Well, the biggest challenge is if you've got an outbreak of a disease or some sort of bacteria that's making people ill from some produce, it's very hard to track, well, where did that produce come from? Well, in past years, they've, like, just a year and a half ago, there was a romaine lettuce shortage. Now, if you eat romaine lettuce, you probably noticed it. Maybe not if you didn't, but Caesar salad is made out of romaine lettuce. So what happened was that the major producer of romaine lettuce was in California. And so they kind of narrowed it down to California. But the problem is they didn't know which farm in California that it occurred. So basically, because they couldn't quickly identify where the source was of the infection, they had to basically take everything off the shelves in multiple states and areas. They shut down pretty much all the farms in California and destroyed just tons of produce. So what blockchain does in that case is that if they get a food, let's say produce, into a store and they find that it was the romaine lettuce at this store, and this store, they can look at their blockchain and see where that came from, down to the distributor that sent it out, the food processor that processed it, all the way down to the farm that actually produced that head of romaine lettuce. And that is really, really valuable because it saves a lot of money, because obviously there was a lot of romaine lettuce thrown away that was perfectly good, but the problem is they couldn't trust it because they couldn't quickly identify where the infection came from. So the first point we get to here is greater trust. With a blockchain, you can get a trustworthy ledger of information that is that is is safe. And Danielle makes the comment. She says that she remembers the romaine lettuce shortage because she's a huge Caesar salad fan. And yeah, my wife and I ate Caesar salads a lot, and they were stripped bare. You couldn't get the romaine lettuce. Yeah. So greater trust, and that's just an illustration of how you can get greater trust. Now we're going to talk a lot about greater security, because just the simple fact that the ledger becomes immutable, meaning that the data can't be hacked as easily either. So you've got a distributed ledger. You've got the challenge with hacking the information is that in order to hack it and grab information or change information, you've got all these ledgers distributed out to who knows where, because the attacker probably doesn't know all the places that have a copy of that ledger. It literally makes it difficult for a hacker to get in and get the data. The second point there is the level of security just in the encryption is very, very difficult to crack, because not only is it encrypted with a thing called a Merkle tree. The Merkle tree gives you a very, very quick, easy way to search through for a transaction, but it also makes it very difficult from the outside if you don't know the public key for that information in there. It makes it very, very difficult to see and understand what the data is. So the block itself is encrypted, inside each transaction is encrypted, and then you've got encryption going in and going out on either side of the block that a hacker has to contend with as well. So it is so difficult to crack it at this point. And at this point, because of the way that blockchain is laid out, it literally is able to keep the hackers out almost by just its native ability to link the data together. Okay. So the next thing is that it's a whole lot more efficient. The data comes in and goes out a whole lot more efficiently. Now, when we talk about efficiency, you got to be careful here, because the blockchain network is not a measure of efficiency. The blockchain network literally is meant to be slow. They do transactions adequately, but it takes about 10 minutes to finalize a transaction. Compare that to the Visa network, and they can finalize a transaction and verify the data within just a millisecond. And the Visa and MasterCard networks both transact a lot more transactions than blockchain does. Blockchain has a real problem if it's going to be extensible and grow to really meet the needs as a currency the way it was originally intended. That's another story for another time. But in business, you don't have the overhead. You have a different kind of validation, a different kind of consensus algorithm. We'll talk about consensus algorithms in future lessons too. A different way to validate each transaction that is quicker and much more efficient than what they call proof of work that is currently employed by Bitcoin. And basically they use proof of work because they're a public blockchain. They have to be able to keep the bad actors out. And the only way to do it is through proof of work. They have to know that each node on the network is literally doing the work it's supposed to be doing and not acting inappropriately. Okay. So this particular site, if you want to go to ibm.com topics, what is blockchain? If you want to take and write that one down. In fact, I'll put it in the chat. That particular site, if you scroll down to the Blockchain 101 in 5 minutes, you can quickly go through these, minute and a half long, minute long videos that'll explain a lot more. And you'll hear it from somebody else other than me, which always kind of helps. I like to hear it from 2 or 3 different directions, and it helps me to learn. Okay. I'm going to take a quick break here and see if anybody has any questions. Okay. Hopefully somebody will come up with questions and post it there. And I am going to go and pull up the next item while we wait for other questions. Okay. Alrighty. So I will take a break when I see a question coming, and I'll answer the question. So feel free to go ahead and put the question um, in the chat room. Okay. So here's another article that I got from, where did I get it? 6 Ways Blockchain will change the way we do business. And so I just want to give you an idea for a flavor of even more things. In fact, I've got a graphic that I've got it buried someplace. I think I show it in one of the videos of 50 different industries that'll be greatly benefited by the use of blockchain. In other words, you can pretty much think of a way to use blockchain pretty much for everyone. I have a question from my assistant. Am I staying full screen on purpose? No, I'm not. So you guys haven't been able to see any of the things I've been showing. So that whole time, okay. All right. This is the way it was meant to be seen here. Putting me in the corner here and you being able to see the document I was referring to. So hopefully that's a little bit better. There we go. Okay. So my bad. I didn't realize that I didn't change screens. Practice makes perfect. I'll do better next week. Okay. So what does blockchain do? And here we're going to get those same 3 words: an immutable, shared, distributed record-keeping technology. And that pretty much sums it up. Okay, good. Jacob says we can see the PDF now. Good. So we're going to hear that over and over and over. It's an immutable, shared, distributed record-keeping system. Please understand that when somebody calls it a database, they really don't know what they're talking, or they think they're talking down to an audience that doesn't understand what blockchain is, and the best thing you can relate it to is a database. But the difference is what makes blockchain technology unique is the security, and it makes it impossible to alter, forge, or breach the data or hack the system where it's stored. That's the biggest difference there. That's going to be the biggest benefit to most companies. So how does blockchain work? Well, they've got this graphic in this article, and I'm going to go ahead and post this article so that you can see it. It just kind of gives you an idea how blockchain works, how you start with your computer, you put in your transaction, and this uses the example of money or currency. Let's see if I can make it a little bit bigger here. There we go. Okay. So it's all put in a block of transactions. The block is sent to every node in the network. Every node in the network then adds it to their ledger. Okay. They validate the transaction and say, yes, it's good. No, it's not. And then if the node then closes the block, they get the reward, as in Bitcoin. They're showing a Bitcoin symbol here. And the blockchains that are going to be in business also have rewards. They have rewards for the processing of the data. Okay, so you'll see that in the business blockchains, that there will be some sort of a token that will have value, and the value pays for work done to maintain the network, or work done to maintain the transactions on the network and close blocks. In any case, there's a token reward that can be exchanged for some value, and it's just mostly a record-keeping system, really. The token is a record-keeping system, okay? And so then the block is added to the existing blockchain, and the transaction then is complete. So the critical pieces are here. The transaction is created and sent to the network. The network then sends it to every node on the network, who then say, yes, it's all good. Everybody agrees. That's called consensus. Once consensus is achieved, the node that closes the block gets a reward. The block is added to the blockchain, and the transaction is done. In simplistic terms, that's exactly what happens each time. So I'm going to go back here. Okay, very good. So the one way that it's going to help is that sensitive financial information, confidential medical data, any of those types of data is going to be greatly improved. Like there's a hospital chain, a medical chain of hospitals and clinics in Japan, and they're running on a blockchain right now. And what that allows the person to do is, just like in a Bitcoin, you have your wallet, and on this blockchain network, you have your data that you can transport from doctor to doctor. You don't have to worry about filling out this form that says that you want Dr. A to receive all the files and the copies of all the files sent to Dr. B. And all you have to do is give them permission to see your data in your wallet. In other words, send them a transaction that says you can have access to this information. Then the doctor has that privileged access, which you can revoke at any time you want. So they have seen it being incredibly efficient, because it takes the nurses and doctors out of the business of managing your data for you and making sure your data gets to the next doctor where it's supposed to go. You end up managing that yourself. And in that same way, you can have more confidence that because you're managing it yourself, you have control over who sees it, when they see it, and how they see it. Okay. So they've got 5 healthcare blockchains if you want to go see those. Okay. Advertising and marketing. 45% of U.S. companies experience some sort of a data breach, and marketing and advertising companies are a significant part of those companies. Marketing and advertising, churns a lot of money through the system. They estimate their losses at $68 billion globally by 2022. Only 59 in 2021. So it's growing very rapidly. People like to steal money if they can get their hands on it. So those data breaches can be prevented by having it in a blockchain. And I remember the data breach at Target. That was a terrible one. They had their credit card system hacked. They had been told for years that their security was lax, and they had some millions of credit card records stolen in the data breach. And because of that, they lost lots of money. They saved it along the way by not repairing their security, only to quickly lose it when their data was hacked. So it's literally it literally behooves companies to find the most secure way to maintain and to hold their data in ways that they can't breach that data. And the old relational type of databases, where all you have to do is hack into a data server area, they're quickly going by the wayside as companies like Amazon Web Services and such, and their blockchain people embellish or add to the security that's available. Okay, so coming down here, the next one, operations. Operations management is a huge place where there is a lot of waste. I just can't believe how much work managers go through just to manage your yearly pay increase, potentially in larger corporations anyway, or manage the payroll data, or manage the information in the HR system. It's really, really tough. And now with the new what they call GDPR, the regulations on global data privacy in the European Union, it makes it even more sensitive that if your HR data gets hacked and you have information on your employees that gets out in the wild, you're going to pay excessive fines to the EU if they're an EU member that had their data stolen. So it becomes really, really important that the HR data is kept private. So Kodak, for example, implemented a Kodak One management platform just for the purpose of keeping their data private and making sure it was digital and secured. So a lot of companies are headed towards that direction. So, okay. And here's more on the human resources. So this was more management, the yearly pay raises and so forth, the yearly appraisal reviews that you have to go through. And then here's the HR data that they're tending to move towards. Okay. Okay. Accounting and finance. I've talked about it quite a bit about accounting and finance. They're leveraging their technology to make sure that the data is secure and you could quickly retrieve it. So that's very, very good. It not only safeguards various transactions related data and minimizes the risk of online frauds associated with these activities, but also provides a much faster and effective solution for online transactions. It's hard to believe that something that is more secure can be faster, but blockchain, and just the inherent way that it encrypts and connects block to block, literally causes it to be faster than a relational database system that is faced out towards the web, for example. So you interface with it from the internet, and all the security that goes into the back end there to make sure that the data transaction between you and their systems adds so much overhead that the system bogs down. And so blockchains, just because of the way they do things, are actually quite a bit faster than all of those systems with all the security that they've added or had to add. Okay. How many do we have? Some people here, I'm sure we do, that are involved in cybersecurity, the cybersecurity major here at Lindenwood. So it's probably a good thing to say that Deloitte, a major accounting and auditing firm in the United States, the CEO there, managing director there, said that blockchain technology has the potential to improve efficiency of the global cybersecurity market. And that market is worth over $130 billion to those people who pursue doing business in that market. In other words, helping companies to secure their data. Those companies look like they've got a market of about $130 billion. And it can help those markets by increasing their efficiencies. And here we have healthcare and medical. I detailed the one hospital in Japan already. And so all of the personal details and diagnoses and everything that you can have in a system, you have control over it, which is nice. Okay. This is kind of an amazing number, I thought here. It says data breaches in the healthcare sector increased dramatically. Statistics say that data breach incidents cost $45,700 per hour on an average during the year 2021. That's a huge, huge number. Okay. So not only this, more than 50% of hospitals that use normal internet are vulnerable to those cyber threats. So what you've got is a situation where, a blockchain backend to a website is a whole lot more secure than a regular SQL database or MySQL database or whatever data structures you have representing the data in your website. Okay. Some of the companies that have adopted blockchain: Medical Chain, Avenir, Robomed, Chronicled. I don't even know most of these. So we could, go ahead and Google those and see what they're doing and see how they're doing it. So the whole idea here is that blockchain is slowly starting to morph and change the industries that they're impacting. It's going to make things more secure. It's going to make things easier to do in the future. Some people liken the new blockchain technology as equivalent to when the internet first was born in the late 80s, early 90s, and that caused the huge boon to businesses such as Amazon, who ran with the new technology and made a huge business out of it. They actually call the they actually call the new emergence of blockchain as the Internet 3. Internet 1 was basically just exchanging data. You had HTML web pages, they didn't do much. Internet 2 led to the rise of videos and other dynamic forms of data exchanges. Internet 3, secure data, really. And so there's a lot of pioneers that are looking at, creating a new internet with more secure backends through blockchain technology. So my voice has just about had it. I've talked for about 45 minutes. Do we have any questions at all? You've been a quiet crowd out there, text-wise. So also, is there anyone else that has joined us that hasn't told me who you are, just so that you can, so that I can give you credit for being here and such? Now, to any of you that want to review anything that was said here, this live stream is recorded, and right afterwards is posted onto my site, Pharos Technology, on YouTube, my channel, and so you can review it afterwards. Use the same link that you used to get into the live stream for this week. That link will take you to the recorded video that'll be probably ready in just a few minutes after we close out here today. Okay. So, since I'm not hearing any questions or seeing any questions, I think I'm going to call it a night. So, I'm going to stick around here and just to make sure there aren't any questions and make sure I work through the time delay, getting out to you guys. Otherwise, see you again next week, and we'll look forward to it. Talk to you later. Bye.